Okay, so let's take a look at the Hyperbolas packet again. And this is going to be the second part video. So this one, if you haven't seen the first couple pages done, then you need to watch part one. Otherwise, scroll down or flip the page to page 3. And page 3 starts with these diagrams here. And if you remember, we figured out for an ellipse that you pick any point on an ellipse and the distance from the focus to the point, from one focus to the point, plus the distance from the other focus to the point is always a constant. Hyperbolas also have foci, so here's one of them, and here's the other one. Except it works different. If you pick a point on the hyperbola, like P right here, then this distance and this distance, if you take the difference between them, then that's a constant instead. Not the sum, but the difference. And so, since sometimes, like if I picked a point down here instead, R1 would be the longer one and R2 would be the shorter. So this one would be R1 minus R2. And over here, R1's the shorter one and R2's the longer one. So the way that you take into account the fact that sometimes this is what you want and this is what you want equals a constant, you just put it in absolute values. Excuse me. Okay. So we're not going to dwell too much on that, but the key really is, excuse me, how do you find the focus points, or how are the focus points related to other aspects? Okay, so the nice thing is it's almost the same sort of relationship as an ellipse. In an ellipse, we know that the distance, so here, I'll just kind of sketch it on the side here. So in an ellipse, you've got your two focus points. Well, actually, we don't even need the focus points. You've got the long radius is A, the short radius is B, and then we figured out this relationship that A squared equals B squared plus C squared, and C would be the distance from the center to a focus point. And it just turns out that that happens to work, and we proved it in class. For hyperbolas, we're not going to prove it, but when you have a hyperbola, let's say that you graphed the one that goes with this, right? So here's the hyperbola. I'll do a different color here for the hyperbola, right? And remember, there are asymptotes that go through here and here. So here's your hyperbola. Well, the A and the B are exactly the same thing for a hyperbola. Whoops. Sorry, let me get the ellipse back here. So there's our ellipse. Here are the asymptotes. And A and B are still the same thing. This is still A. This is still B. But notice now the distance to the focus for a hyperbola is the longest part, right? And there's still a Pythagorean relationship. It's just that now the distance C is the longest one. So C squared equals A squared plus B squared. That's for hyperbola. And in fact, you can build that right here. Turns out that this length right here is C, because here's A, there's B. This length is C, and if you just rotated it down, it's the distance to the focus from the center point. So this is the key for finding where a focus point is for a hyperbola, right? Hyperbola only. So let's try some problems. All right. So write the equation of a hyperbola with vertices at 4, -2, and 4, 6. Okay, so here's a vertex, and here's a vertex, and foci at 4, -5, and 4, 9. So this is a focus, and this is a focus. Okay, so you can kind of picture, remember, if this is your hyperbola, the foci are here and here. So for this, the hyperbola is going to open out like that. Something like this. Okay, well, we can figure out a few things. One thing we can figure out is, where's the center of this thing, right? Well, here's the line that goes right down the middle. The center is roughly here. Well, to get the center point, well, it's the average of 4 and 4, right? If I'm going to average the x's of these guys. So the average is 4. And then if I average 6 and -2, then I'm going to get 4 over 2, so that's 2. So the center point is 4, 2, right? That's the center. So then I know that the hyperbola has an x minus 4 and a y minus 2 in it. Okay, so what else can we get? We can get that the distance from the center to a vertex is 4 units. Right, so that's 4, this is 4. And let's see, what else? We don't have the little rectangle to build here, but we know that it would look something like this. The only problem is you don't actually know if the 4 is the A or the B, because maybe the rectangle's like this big, right? So 4 equals A or B. We're not really sure which one, right? Let me get rid of this. We do know also that the distance from the focus to the center is C, and that one we can figure out it goes from 2 to 9, so C is 7. And the relationship between C, A, and B is C squared equals A squared plus B squared, right? So I know that C squared is 7 squared, and I know that equals either 4 squared plus B squared, or A squared plus 4 squared, because I don't know which one 4 is. But I know it's one of these two, and it doesn't matter which one. So I'm just going to put 4 squared plus, and it's either A or B squared, right? A or B. Not sure which one. The bigger one is going to be A, and the smaller one will be B. So we'll just figure out what it is. 49 equals 16 plus something squared. If I subtract the 16, I'm going to get 33 equals something squared. So the something is going to be root 33. And if you turn that into a decimal, that's about 5.745. Okay. Well, that's bigger than 4, so this one turns out to be the A, and the 4 turns out to be the B. So I'm just going to cross that off. That's B. So 4 is B. And 5.745 is A. Or root 33 is A. We'll leave it as root 33 so it's exact. Okay. So that means that I'm going out root 33 each direction. So my rectangle is actually wider than I drew it. I'll just do send there. So it's root 33 out, root 33 out. Right, so here's the rectangle. All right, so, and root 33 is the A. So then we need to write the equation. All right. Well, notice that the parabola opens up and down. Remember, when it opens up and down, that means that the y term is the positive one, and the x term is negative. So it's going to be y minus something squared minus x minus something squared equals 1. And then we've got to divide by the stretches. Okay, well, the stretch vertically is 4. The stretch horizontally is root 33. And the center point was 4, 2, so the x1 is 4, and the y1 is 2. And there's our equation right there. Okay. All right, let's try another one. So we'll flip the page, number 6. Graph this hyperbola. So it's 3x minus 5 squared minus 8 y minus 4 squared equals 48. Okay. So let's see. One thing that we need is we need to get it to be 1 on the 48 side. So we'll divide everything by 48. And let's see. 3 over 48 is 1 over 16. So that's going to be x minus 5 squared over 16. Whoops, 16. Minus, and then 8 over 48 is 1 over 6. So y minus 4 squared over 6 equals 1. And then we want to kind of put it all in big parentheses here. So this will be x minus 5 over 4, and y minus 4 over root 6. Okay, so let's see what we've got. We know that the center is going to be 5, 4. We know that the horizontal stretch is 4, and the vertical stretch is root 6. By the way, root 6 is definitely less than 4. That's only about 2.45. So this one's B, and this one's A. The x term is the positive one. So that means it's going to open this way. left and right. And we're going to need the foci too. So to get the foci, we need c. And remember, for hyperbolas, c squared is a squared plus b squared. So c squared is going to be 4 squared plus root 6 squared. So that's going to be 16 plus 6, which is 22. So c is root 22. And again, I'm ignoring the negative root because it's a length. So that's what we need to plot them. So let's go ahead and plot them. So I'll do blue. So the center point is 5, 4. That's right here. And then to build the rectangle, we got to go 4 in each direction, left and right. So there's 1. 1, 2, 3, 4, right there. I've got to go 2.45 up, so 2 and about a half, and 1, 2 and about a half. So here's my rectangle. Oh, where's the pen? There it is. We'll sketch the asymptotes. So that goes right through here and here. The hyperbola itself opens up left and right, so that's this side and this side, and we use the asymptotes to kind of guide where that green curve should go. We need the vertices, so this vertex, remember the horizontal stretch was 4, so if you go 4 away, we're at 9, 4, so there's a vertex. And then this one would be 1, 4, that's a vertex. Let me put the 9, 4 here. Vertex is 9, 4. Let's see, what else do we need? We need the foci. Okay, so the foci were root 22 away from the center. So root 22, I don't know, that's a little less than 5. So if I go a little less than 5 away from the center, so 1, 2, 3, 4, and a little less than 5, so somewhere around here is one focus, and somewhere around here is the other focus. And really the coordinate, I had to go root 22 this way and root 22 that way. So I'm just going to say 5 plus root 22, comma 4, and 5 minus root 22, comma 4. And if you wanted to, so this is a focus and this is a focus. I'll move that a little bit closer. Let me get rid of these arrows here. And if you wanted to convert that to decimals, that's fine with me. I'm not going to be picky. Let's see, what else? Oh, the asymptotes. All right. So we've got an asymptote right here. And we'll use point slope form, so that's y minus y1 equals mx minus x1. And we already know that it has to go through the center point 5, 4. So I'm going to do x minus 5 over here, y minus 4 over there. And then we need the slope. Remember, we have a little slope triangle right here. And the amount that I had to go up and down was root 6. And the amount that I had to go left and right was 4. So the slope of this line is rise root 6 over run 4. So this is a root 6 over 4 right there. And there's the equation of that asymptote. And then down here, for this bottom asymptote, it's almost the same slope, except now it's going down root 6 instead. So this slope is negative root 6 over 4. So then the equation is going to be y minus y1, which is the center point, 4, equals m, negative root 6 over 4, x minus x1, and we know it goes through the center point, so I'm going to put 5 there for the center. And there's all that info, ready to go. All right, I hope that helps a little bit.